In this, my fifth video on helping people study for Actuarial Exam 2, we're going to be taking a look at problem 1.2.7s in Broverman. It's about determining the interest rate for two equivalent payment streams. Here's the problem. David can receive one of two payment streams. The first one gives him 100 at time 0, right now, the present, 200 at time n, and 300 at time 2n. The second one just has one payment of 600 at time 10. At an effective annual interest rate I, which is, look ahead here, that's the thing we want to find, the present values of the two streams are equal. We're also given the value of v to the n, where v is the present value discount factor, v is 1 over 1 plus I. By the way, you can always solve that for I in terms of v as well. Take the reciprocal both sides and then subtract 1. I would be 1 over v minus 1, which if you like can also be written as 1 minus v over v. This problem is simple enough, I think, that you don't really have to draw a timeline, but just again as a matter of habit, I think I will. And just in case it's difficult for you to conceptualize. Here we are, time 0. Let's say here is time n, and here is time 2n. Where is time 10 in here? It's hard to say for sure. Maybe it's over here. Let's just pretend it is. Let's say time 10 is there. All right, you've got these two income streams. The first one gives you 100 right now, gives you 200 at time n, and 300 at time 2n. And the second one is just one payment of 600 at time 10. What does it mean for the present values of the two streams to be equal? It means if you find the present values, they will be equal. In other words, if you take 100, which is already at the present moment in time, so I don't need to discount it, I don't need to pull it back in time, plus the 200 discounted by n years with the factor v to the n. That's the multiplication factor that you need to multiply that amount by to get its present value here at time 0. And the 300, 2n years in the future, gives me this. That needs to be equal to the present value of the 600 at time 10. I need to pull the 600 back in time by 10 years. I need to multiply 600 by v to the 10th. I want to know I. If I can find v, that'll help me find I with this equation up here. These quantities over here on the left, I can calculate based on what I'm given. I'm given that v to the n is 0.75941. I can put that in there, and I can square it, since v to the n squared is the same as v to the 2n, to put that in there. I've been typically storing things on my calculator in recent videos, but this time I think I'm going to just write the numbers down. And if you have trouble storing numbers in your calculator, if you get confused in the pressure of the moment about how to store things and recall things, then it's probably better for you to write things down. So we've got the 100 plus 200 v to the n. I'm going to take the 0.75941 and multiply it times 200. That gives me 151.882. Then I'm going to take the 0.75941 and square it to find the v to the 2n. So I'm going to square that. Just use the squaring button right there if I like. Here it is. Square it. Multiply by 300. And I get 173.01106444. That equals 600 v to the 10th. We don't know what v to the 10th is yet. So now I need to add up the numbers on the left. I'm going to have to divide by 600. That'll give me v to the 10th. Then I'll take the 10th root of that to get v, take its reciprocal and subtract 1 to get I. So we are getting close to being finished. This is one of the easier problems, I think. Adding backwards across this line gives me a left-hand side equal to 424.89. I won't bother writing that down. I will now divide that by 600. Divide by 600. The value of v to the 10th looks to be 0.708155107. You could write that down if you like. I will now take its 10th root. In other words, raise it to the 0.1 power. I'll use my power button there. Y to the x, and then 0.1 is the same as the 10th root. And that's the value of v. Let me go ahead and write that down, even though I don't really need to here. 0.966079439. Now take the reciprocal of that and subtract 1 from it. Use my reciprocal button. Here we are, sorry about the lighting. Right there, 1 over x. Subtract 1 from that. I is about 0.03511. And that is the correct answer. That would be the interest rate. And that will be the end of this video.